Hello, everyone, and welcome to this Telit webinar, Why OnGo Dedicated Cellular CBRS Networks Are a Game Changer for Commercial and Industrial Enterprises. I'm Amanda Flink, Head of Global Events here at Telit, and I will be moderating today's event. Before we start, we'd like to gauge an idea of your interest in dedicated OnGo CBRS cellular networks. So if you could, please take a second to fill out our poll question, which you should see on your screen now. Now let's get to know our speakers. To explain this topic today, I am pleased to be joined by two speakers. First, we have Safi Khan, Regional Product Marketing Director at Telit. And second, we have Daniel Quant, VP of Strategic Development at Multitech. Just before I hand it over to Safi to start the presentation, I've got a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those at the end of the presentation. Simply submit a question by posting in the box to the right of the slides. Also, please be sure to check out the resources section in the upper right-hand corner of your screen for additional information. Finally, we will send out the presentation slides and a replay link to all attendees at the conclusion of this webinar. And with that, Safi, I will hand it to you.
Thank you very much. Hello, everyone. Very good to be here today talking about CBRS and private networks with all of you. So let me jump right into it. I want to start by talking about the growth of the cellular market, just to make the audience understand what is really happening in the market. So this chart shows the growth of cellular IoT connections. And as you can see, it is expected to reach about 4 billion connections in the next 5 years. So that's pretty good growth with a cumulative growth rate of 30%. And the ecosystem is very strong. Most of the growth is actually coming from 4G and then 5G, especially in the next 5 years. It's happening both on the high end for high bandwidth applications, as well as on the low end, such as narrowband, NB-IoT, and LTE Cat-M for machine-to-machine. Both of these categories are having high growth, whereas on the other hand, we also have legacy technologies such as 2G and 3G, which are mostly flat moving forward. And in fact, 3G is, for example, in North America, going to be seeing its sunset very soon. So now 4G has pretty much become ubiquitous, and 5G is quickly behind 4G and bringing many new features that we will talk about today's presentation. So LTE technology is mature and flexible, and also because of the economies of scale, it is reducing in cost. The one area where the cost is higher than, for example, other wireless technologies like Wi-Fi is the licensing fee. And because the cellular spectrum traditionally has been licensed, it has been very expensive. So today we're going to talk about shared spectrum. So in that case, the spectrum is available in a few tiers, which is lowering the cost of LTE, and hence the private LTE business that we want to talk about today, especially in the enterprise. Okay, so let's talk about current wireless technologies that are used in for connectivity in basically on-site venues. This was a survey conducted by Beecham Research, and according to them, as you can see, 86% of the respondents said that they use Wi-Fi for connectivity, which makes a lot of sense. Wi-Fi is low cost, it's easy to control and deploy, especially indoors. On the other hand, for longer range, there is Sigfox and LoRa. These two technologies are able to cover longer range applications like outdoor, agriculture, farming, mining, etc. However, the data rates are very low in these technologies. Bluetooth also came in at 43%, and again, Bluetooth is great wireless technology, but very good for short range. So in the short range, Bluetooth is used by many entities. And then cellular, which we want to talk about today, excuse me, came in at 48%, and this is what we want to focus on today. And cellular has some of the advantages for enterprise that will become clear as we move along. So let's get into basically the topic today. Now that you know, excuse me, now that you know a little bit of background on the market and the technologies, let's find out what is private LTE and why is it important. This may be repeat for some of you, but it is important to just touch on these things as a reminder, and also it may be useful for those who are not familiar with private LTE. So it's a dedicated network for an enterprise. It's basically separated from the wide area macro network. It is used for specific IoT applications and services. It targets specific verticals, like I said, like mining, industrial manufacturing, automotive manufacturing. Also, the utilities are using private networks for their connected meters, logistics hubs, many other applications like smart cities, transportation hubs, hospitals and medical, and then enterprises, which we will cover today, campuses and stadiums. So many use cases for a private cellular network. It can be operated by a mobile network operator or by a new private incumbent company that wants to get into managing and owning an entire portable private network. Now, one misnomer is that private LTE is only in shared spectrum. That's not true. Even the licensed operators can assign some of their licensed spectrum to be operated as a private network for a service that they offer, and they could cut out a slice of their macro network and make that available as a private network. Along the same lines, private 5G would be a natural evolution from private LTE. It would bring all the benefits of 5G, such as enhanced mobile broadband, massive machine-to-machine communication, and IoT to the private networking space. It also will bring network efficiency. The core network is more efficient, and also ultra-low latency and high reliability. We will touch on those as well. So within comparison of private networks, private LTE networks to, for example, Wi-Fi, let's talk about security. So as it's well known, we've all heard the stories of how Wi-Fi is a target of hackers, and it can be hacked more easily. One famous example was that some Russian hackers got into the casino in Vegas through the network, and the way they tapped into the network is that they had a big fish tank with a Wi-Fi controlled thermostat, and these hackers targeted that Wi-Fi thermostat, they hacked it, and through that they were able to gain access to the casino's network. So when enterprises and industrial manufacturing complexes and, for example, city infrastructure, they want to upgrade their security, they look towards cellular LTE because it brings higher level of end-to-end security. Also because these networks are basically built with this security in mind at the very from end-to-end, from lower level to the higher level layers of the stack. The only downside was the LTE cellular networks cost more than Wi-Fi, and they were looking for lower cost alternatives that are more secure than Wi-Fi. And that's where private LTE enters, and it's lowering the cost and competing with Wi-Fi in many respects. We also already talked about latency. as you can imagine, manufacturing would like to have low latency in their wireless networks so they can exploit it in many different use cases. So especially with the advent of 5G, we will see a dramatic shift in how the industry basically uses wireless technology inside a manufacturing environment and many other use cases as well. So this is a kind of a brief background on what is private LTE and why we think it is important. And we will touch on more aspects as we move along the presentation. So this is a very kind of a conceptual view of a private cellular network convergence, if you will. And the way that we view this is basically that there are three tiers that are converging together. And so let's cover them. So in the left side is the low-end LTE Category 4, Category 6 IoT. So this would be low data rates, 10 to 150 megabits per second, maybe up to 300 megabits per second. And this can be used by many, many different use cases, like in sensors. It's shown a charging station here. Basically, any kind of outdoor or indoor infrastructure that needs connectivity can make use of the low-end LTE in a private LTE setting. Once you move a little higher, we see a lot of action in the mid-end. And now you're talking about Cat 12, and that's about 600 megabits per second downlink. And here you can also bring in the kind of the robustness of LTE cellular coverage, and you're basically having a broadband connection for, let's say, mission-critical operations, as shown here, where like first responders going to a remote site can put up a private LTE network very quickly using a portable battery-operated box, for example, and an entire core network can fit in a portable rack. And that gives you this instant broadband. And, you know, with today's COVID-19 situation, this is also a very relevant use case for pop-up medical use cases where if you need emergency medical center to be built up quickly in an outdoor setting, you could use private LTE for that use case. And last but not least, on the high end, we are seeing that private 5G NR, the new radio, brings in low latency and also mission critical systems. And as I said before, this upheaval that's happening in the market, where, for example, robots could be fully autonomous and fully connected to each other, as well as to the basically the enterprise network of a factory. They can make use of a private service. And OnGo is basically the name of the private LTE service powered by the CBRS Alliance, which we will also talk about. And so this is the entity that is providing the basically the framework and standard specification where many of these nuts and bolts come together of different companies working together to build this private network. So with that, let's dive in a little bit into a couple of slides on what is comprised of CBRS. So CBRS stands for Citizens Broadband Radio Service or System, and basically this is, so North America is kind of the leading country where private spectrum is basically undergoing a massive excitement in the industry and lots of business development happening around it. We will talk about auction later on of the spectrum. But essentially what it is that in the 3.5 gigahertz band, the FCC has granted the use of this spectrum in 3 tiers. So there's incumbent Navy radars in the coastal areas of the United States where this spectrum was used by the Navy. And now they are opening it up for new entrants as long as they adhere to certain rules to make sure that the radios turn off when the Navy is using it, which will be controlled by a well-defined system. And in other times when the Navy is not using it, this spectrum will have 2 more tiers. One is called PAL, which is the Priority Access License, and that's what we will talk about. There's an auction going on for this piece of the spectrum. This will be auctioned by the FCC. And then there is also the sort of the free spectrum, which is very attractive in terms of lowering the cost of LTE, and that is the GAA, or General Authorized Access. So this is from a very high level what a CBRS system looks like. And with that, in the next slide, let's look at some of the key components of the private LTE network. Now here, let's look at some of the acronyms that you may see. So ESC is Environmental Sensing Capability, and SAS is a Spectrum Access System, and CBSD is a CBRS device. So on the left, what's shown here is there are multiple these SAS or SAS providers, and these the job of the SAS provider is to basically build a system that follows the rules laid down by the FCC. So they provide these ESC or sensing units to look at when the Navy is transmitting, for example, and let the other devices know to turn themselves off, and also to basically allow access to the rest of the devices. On the right, there are a couple of example use cases that show an enterprise private LTE network, self-contained, or a neutral host network, for example, providing service to multiple operators for enhanced capacity. So these basically are the nuts and bolts of how a CBRS network works. Within the CBSD, there are 2 device classes. There is the Class A, which is the indoor small cells, and then there's the Class B, which is the outdoor base stations, and Class B is allowed to transmit at a higher power, and the Class A has to remain below a certain power level. And some of these are basically talking to the SAS system constantly to know when they can transmit and when they have to turn off, and so on. So this is how basically a CBRS network operates. There's more to it that you can learn. Basically, it's not fair to cover it in such a short time, but due to the lack of time, I will move on. But we do have lots of material. You can go to CBRS Alliance website for lots of information, and you can go to the Telit website, and we have also more information about CBRS. Okay, this is a very interesting and important slide from a interest of the audience perspective. Like, what are the typical sites that a private network can be deployed in? So as you can see the pictures, you see shopping malls, airports, shipping ports, and warehouses. So the idea is that because cellular has longer range than Wi-Fi, especially outdoors, yes, you could have a Wi-Fi network, which is low cost, but with the advent of private networks and with the shared spectrum model, it is now feasible and viable to actually deploy LTE technology, which is a 3GPP driven technology, which has the whole ecosystem and backing behind it, deployed in a way that basically all these different use cases can be served. And I think Dan will do a great job in basically going and drilling down into use cases that they are seeing where private LTE products are getting deployed. So this is what high-level typical sites are for private LTE and private 5G. Now I'll just come to my last slide to show you that Telit is one of the leaders in this space, and we have a portfolio of basically embedded modules, data cards, that can be used by any device that is trying to connect to the private network. And basically what the module has to have is support for what we call mid-band or 3.5 gigahertz band. And that's basically also called band 48 in the United States. So this one product in the middle towards the left is the LM960A18. This is a gigabit LTE module that also supports the private LTE bands. And this is one of the only gigabit LTE modules fully certified on all the major operators worldwide. It's a global SKU. And this one is basically CBRS certified. Next, we have the LM960A9-P, which is basically the private LTE only version of the LM960. And this can do band 42, 43, and 48. Next, we have the low end covered with Cat4 and Cat6 devices that basically could be used in very low cost CBRS devices that some of them Dan will talk about. And lastly, we have M.2 form factor Cat6 and Cat12 devices coming soon, which will also have CBRS band coverage. So for any of these, you can look at some of the resources page links when you see the slides that are sent to you. So with that, I conclude my part of the presentation, and I would now just hand it back to Dan to take it from here. Dan.
Right. Thanks, Safi. You hear me?
Yes, we can hear you.
Right. Great. Well, thank you for inviting me to this webinar. Very much appreciated. So let's have a little look again at those typical sites, shall we? So those typical sites are the enterprise, right? And the enterprise has been deploying their own private networks like Wi-Fi for years. And many of those enterprises like utilities, oil and gas, transportation, mining, they have decades of experience deploying all manner of different types of private wireless networks. And why do they do that? Well, they do that because they're looking for improved reliability, security, performance, and control. Each one of those enterprises is on its own digital transformation journey, and it's looking to create a more data-driven system, right? A way in which they can improve their customer relationships and their customer experience, like Amazon doing targets of 8-hour click to delivery and stretch targets beyond that of getting down to 3 hours. And it's also about efficiency. And when I say efficiency, I don't just mean cost savings, but I mean taking companies as diverse as mineral extraction and retail and moving them into the 21st century, taking their processes and their assets and being able to automate that and automate their business, making them more efficient. And LTE plays into this really well because LTE has a broad ecosystem. It's a standards-based technology, and it's very much an industrial IoT architecture, which is quite flat, device, network, platform. It's a flatter architecture that can do well in these environments. Particularly when you look at how it can be capitalized. We always imagine cellular as being a public network where we pay no matter how many devices we have on the network. Any new device has a data plan that costs us per month, per device for the life of the asset. And that can eat you away after a while. And it turns out that you don't actually need that many devices, particularly if they're clustered within your own facility. Don't need that many devices to be able to put up your own network and break even, perhaps 2 years or less. And if you think about most enterprises, they have key places where their business happens, like refineries or plants like this image, or it could be retail, or hotels, or whatever. And that's where the enterprise does business. And lo and behold, that's where the enterprise has most of its assets. Most of them are in those buildings. They're static assets. And what they're looking for is a network that can cover those assets. Many of those assets are in difficult to reach places, like, even in a commercial building, the basement is where all the control systems are at. And it's not easy to get a public network signal into your basement. The enterprise is looking to create high availability. By that I mean that they have clean, quality spectrum with good range, good performance, that any of the devices in their facility can get on quickly. And not just quickly, but with a deterministic performance as well, so that every time that asset is getting the same type of latency and data rate, for example. And of course, security plays into this big time. This is all about data privacy as much as performance and capitalization. This is about, perhaps in, again, networks like this image here, the data never leaves the building. The data is feeding control systems and distributed systems within that building. And all of that data is remaining on-prem, and really important here, especially in more mission-critical environments, it's off the internet. And because it's a secure IP to the edge, it makes it manageable and scalable by IT. So let's have a little look at some of those benefits of OnGo. There always feels like there has to be a villain here, doesn't there? It's always like the analysts and the media, they always pitch a new technology against some other technology, like Wi-Fi, for example. It would be the Wi-Fi killer. But there really isn't an enemy here. OnGo is about providing broad connectivity to a whole range of assets in different and diverse environments. But if we have to pick a nemesis, let's go with the wire. It's all about removing the wire. And that's because the wiring has a significant cost of deployment. At Multitech, we, a few years ago, did our whole building for heating and ventilation. Took forever, cost loads of money, in part because they had to run cables all through the building to connect up all the thermostats and the ventilation system and the air conditioning units and everything else. And imagine if you didn't have the cables. Imagine if you could just put things anywhere you wanted and didn't really have to drill into the walls and run cables everywhere. Imagine a production facility. You can move production facilities around to be more efficient for different types of products and have that flexibility to move all that equipment around and not be tethered to cables. You could be able to connect underserved assets where perhaps cabling doesn't exist. It's often overlooked and forgotten about until, we need to connect it. Of course, you get the improved performance. So you get a dedicated network with your own spectrum. You get enhanced mobility and range. Unlike Wi-Fi, this technology allows high-speed mobility, seamless handovers, and longer signal ranges. And you get great capacity on band 48, which is the 3.55 to 3.7 gigahertz, that enables you to have high data rate applications and a large number of devices connected at the same time. And you can optimize your services, and this is where it starts to get enterprise grade. You can start to provide customized and improved service by allocating quality of service. Quality of service is much talked about, but in public networks, rarely used. In private networks, you can prioritize traffic from a high-value asset versus a best effort attempt to perhaps connect up a tablet. And with that, of course, comes service level agreements that you can push through into your customers. And of course, you get broad interoperability. This is a standard, remember. So a lot of different manufacturers of equipment, everybody's stuff is interconnecting with each other. And of course, 5G, it's here, it's starting to disrupt. Release 16 is all focused on mission critical, ultra reliable, low latency connectivity. What is that? That means process and control automation and cross-vertical integration. That means that networks in a production facility or in an oil rig or a utility network can connect many different assets. Instead of having many different networks, you have one network that can connect everything together. All these distributed systems that are all feeding data into each other. The silos can be removed and reduced. AR, VR, so that you can see how your assets are put together, how to repair them, chemicals, compressed air, hydraulic fluid that needs all of those assets to go to those assets to make them optimized and get best performance. All of that has visibility across all of those distributed systems and down to sub 1 millisecond latencies. And of course, everything that you're buying for CBRS now is essentially 5G ready, and so you have that investment continuity. So it was all smiles. This picture was, I guess, about a year ago now, and it was about maybe 6 or 9 months before the FCC went live with the full commercial deployments of OnGo in CBRS back at the end of January this year. So this was a good 6 to 9 months before that. And already you see Commissioner Mike O'Reilly there smiling from ear to ear because the ecosystem was all in place. You see those blue multi-tech devices in the background there, and a number of other companies with their devices. So this ecosystem was ready to go long before the government pressed the go switch on it, the go live switch. And so I tried here to really show how broad this ecosystem is, and I apologies really to anybody's logo that I missed. With 176 members now of the CBRS Alliance, I just couldn't fit you all in. I spent long enough doing this. But what I'm trying to show here is that there's modules and devices from companies like Cellular, Multitech, Qualcomm, Sequence, but there's a broad ecosystem of infrastructure vendors here making base stations, small cells, core networks. It isn't just about the big MNOs. There's a huge number of service providers here, hundreds, thousands of them as wireless internet service providers, and service providers that are working in every market segment. With really deep domain experience in some of those segments. You have a very talented group of system integrators. You have companies out there like Pearson and Externet who can go from site survey of your building to deploying your equipment to managing that network for you. And you have a really active set of distributors and value-added resellers out there where it's never been easier to get this equipment and have it delivered to you. You have the hyperscalers doing the data management like Amazon and Azure, and they're working with many of the logos in here today to sort of wrap this all up into turnkey services at data management. And of course, a big shout out to the SaaS vendors who really brought the secret sauce here that makes the magic of CBRS happen. So here's a graphic that I picked up from the Small Cell Forum, and it's a pie chart, and you see all the pizza pie slices in there of different market segments. And so what I've done is, and I've kind of grouped a few of them together. So if you take manufacturing, transportation, utilities, and energy, you have about a third of the market there. And I would call that industrial. But it's interesting that almost a quarter of the market is government. You see at the bottom there, you've got 10% of government, so that's more federal, central government. But then at the top, you've got 13% of local government. And that's municipalities, school districts, things of that nature. So that's almost a quarter of the pie there. And then, of course, you've got hospitality, entertainment, healthcare, 15%, retail and office space being perhaps 15% or more as well. And so what you start to see here is that the OnGo ecosystem continues to mature to service its customers in their markets. And its customers have a different take on how they want to deploy that OnGo network. So what you see here is 3 very popular ways to deploy an OnGo network. You have the pure industrial space here. So this is the network in a building. Perhaps much of that network never even leaves that building. It just drives distributed control systems within that facility. And you've got companies in here like Redline who are servicing oil and gas fields and offshore rigs with private LTE. And that's exactly their customer, and it's their market and how they deploy those OnGo networks. You also have other types of networks that are in real estate and hospitals and offices. A lot of the data is coming in and out of the building, but because of poor signal reception, security reasons, capitalization and what have you, there's a dedicated network in there for a broad range of assets from suppliers and partners to be able to use whilst in that building connecting those assets. And USA Security is putting a lot of surveillance cameras into those kind of environments. RF Connect and Boingo and Ruckus and AirTower and True Access, they're very much in that space, working those types of deployments. And then there's hospitality. So this is more of a neutral host network, like say a sports stadium. You come into the sports stadium, you perhaps don't realize, but your handset has handed over into that network to get the better performance and data rates. And the owner of that network perhaps makes a little bit of money backhauling that data back securely to your service provider. And companies like JMA and Geoverse and Cineverse are very active in those markets. So 3 quite different ways in which you can scale OnGo depending on your type of customer, and starting to see the ecosystem now mature into those spaces. So let's start having a little look at specific applications now, and let's start looking at how they're used. So most enterprises have a place where they do their business, or they have different locations. They have their HQ, maybe they have warehousing facilities, rail yards, office buildings, whatever it is. And all of those smart buildings and facilities, they share, the same basic drivers for why to put in an OnGo network. It's all about low latency, high broadband data performance, that agility to connect assets wherever you want and have assets being mobile rather than tethered to cables. It's about creating a high reliability network where you're always connected for your applications in your facilities, your campuses, your buildings. And it's about managing the traffic to be efficient to the types of use cases, be they business critical or mission critical. And of course, that access to spectrum. CBRS comes in 10 megahertz chunks. That's a lot of spectrum, and you can scale it up to 20 meg, 40, and perhaps even more than that in GAA. So let's look at a few applications here. We've got video surveillance. Well, we're all aware of, the eye in the sky, but a lot of these applications aren't just CCTV style streaming video constantly of, an entrance to a door, for example. Increasingly, these are really the combination of pixels and processing power, where a lot of AI and machine learning algorithms are running. And it's not always the footage that's being consumed by a platform. It's often the metadata that those algorithms are generating. So that could be, traditional theft, reduction, right? But it's also things like in-store performance in retail environments. How long do people sit looking at advertising? How long are they at the shelves looking for what they need? And that kind of data is golden in a business like retail. In buildings, it can also be used for occupancy. So which parts of the building have the most traffic in them and the density of people, and which parts of a building perhaps don't get much foot traffic. And maybe we could optimize our cleaning schedules so that the areas that have high foot traffic are perhaps cleaned, every few hours or after every day. Whereas the other parts of the building that didn't get much foot traffic, perhaps that's, every couple of days, once a week, whatever it is. And there's health and safety applications as well. If you imagine something like an oil rig, when a worker walks into a dangerous area and equipment has been tagged out and locked out, which means it's not able to work, there's no way that an operator can override those controls. Maybe an operator doesn't see that his colleague has moved into that dangerous area. And so cameras and AI can lock out that equipment and make sure that that worker remains safe. So video surveillance isn't just about images. It's so much deeper than that now. Rail yards, of course, can use CBRS. They have a lot of worker productivity use cases going on, but also autonomous train shunting. I mean, this isn't about the autonomous train that goes from coast to coast. This is about just shuffling trains around within yards and not having to have drivers go out there and do all of that. And then, of course, there's a lot of these autonomous robots. Many of you may have seen this in places like Target, where you see these little robots looking at stock and in warehousing facilities, moving stuff between different areas of the warehouse. Of course, robots in production environments. All of these types of applications can be connected on a reliable OnGo network. So one of the things I touched on earlier on was the converged network architecture, and that's really about voice, broadband data, and even low bitrate IoT sensors, all aggregated onto one network. That one network may comprise of different RF technologies, but it's all anchored into an umbrella network that is an OnGo CBRS network. So, for example, you would have handsets, perhaps iPhones, Pixels that are supporting band 48, and those devices are natively connected to that 4G, 5G OnGo network. But just because you put a new wireless network in doesn't mean that you're going to replace high-value assets. Instead, you can use routers and gateways to be able to connect those high-value assets then back in to your OnGo cellular network wirelessly. And you can extend the range of Wi-Fi. Instead of only having Wi-Fi access points where you have cabling, perhaps the ISP feed coming in from the street, now you can put Wi-Fi all over your building because you can backhaul it over CBRS. And the same is true with technologies like, say, LPWA, LoRa, and LoRa technology, for example. LoRa is an RF that is optimized for range and power consumption so that small little sensors can run for years and years and years in underserved environments like deep into the basement of a building. And OnGo can be used again to backhaul of that. And what's happening here is that the enterprise is leveraging the best KPI of low latency, broadband, high data rate backhaul with a front haul technology that's optimized for legacy or other types of assets that are in his environment. So let's have a deeper little look at some of those use cases. So here we have an oil and gas pump-off controller. Many of you have probably seen these assets, going up and down. And there's a lot of different variables that are looked at on these devices. So how much pressure on the down, how much pressure on the up, is the rod, hitting at the bottom of the well, how much is being extracted out on the extraction uptake. And, they call all of these values tags, and there are loads and loads of these tags. Typically, these types of devices are polled once a day, and it just tells you all of the tags on the last cycle. It doesn't even tell you averages. It doesn't tell you what the spread in the day of all of those averages were. It's just a poll. And maybe it was shutting down just as it was being polled, in which case all the figures are going to be, not so great. And so by providing broadband connectivity on clean broadband spectrum, like 10, 20 meg of CBRS, a lot more data can be pulled off of these machines. These machines can move to an exception basis rather than polling. And in a field where you may have thousands of these pump-off controllers, you can now have them all working together in order to maximize the yields and the performance coming out of that oil field. And here we have an Ethernet bridge which can easily connect those types of devices directly into a CBRS OnGo network. So let's have another little look at an oil and gas use case here. So this one is about bringing Wi-Fi around the oil field. So although the oil field is covered with a Wi-Fi network, there's lots of dead spots. As you can see, there's a lot of metal, it's very industrial, there's a lot of RF noise in these environments. And so the workers are constantly complaining that they have erratic, unreliable service. Well, instead of just removing Wi-Fi, and there are a number of assets, tablets, and what have you that are on that network, instead take something like an industrial router here, like this RCell 600, put it inside a vehicle, connect it up to the battery of the vehicle, put some antennas around the windscreen, and now you have CBRS OnGo connectivity all over the oil field. So that's your low latency, broadband, high-speed backhaul network. And inside this truck, you have awesome Wi-Fi connectivity because you're never more than a few feet away from it. And when you park up at the entrances to some of the buildings around the oil field, that bubble comes with you. Net upshot, better productivity and improved efficiency for the workers in the oil field. And let's look at yet another use case here. This one is looking at how different types of RF networks, tributary networks, in this case, a LoRa network, is being used to connect tank monitoring of emulsifier fluid at the wellheads. And this enables them to more efficiently push oil down the pipelines and get more capacity into the refineries. And these tanks are all over, they're spread all around, thousands of them. And of course, some guy used to come out with a dipstick, measure it every day. Oh yeah, this one's full, this one's not. And so now with this system, they can automatically see which tanks need replacing with chemical and which don't. And by using OnGo as that backhaul network, again, you get the best KPIs for the total solution. You have broadband mission critical style connectivity on the backhaul, and you get deep connectivity to many different sensors running on batteries for years in difficult to reach locations. And it doesn't just stop with oil and gas, for example. Here we have an example of a construction hard helmet. And construction is one of the largest industrial segments globally, yet it's arguably the least digitally transformed. Wake cap is a great example of worker safety and construction efficiency. It's simple to wear, it's just like every other hard hat, and it doesn't have any privacy issues because it's not like you're wearing this in your personal life. This is something that you put on when you go into the office being a construction site. And so it's designed to be able to accurately track, using a mesh network here, all of the workers. It knows where they are. It knows how long it took to get from the main site, maybe in this image, all the way up to the top of this building to where the work is being scheduled. And you can see where the dangerous areas are. You see it in red here up in that analytics image. And you can see who's in those dangerous areas. And if you need to evacuate, then you know who's left and you know who's left in those dangerous areas. It also has an automatic fall detection, so clearly that brings emergency care to you quicker in the event of an accident. Those little anchors at the bottom, they're all over the construction site. They provide the mesh, and they themselves have temperature, humidity, and pressure, so that the environment that your workers are working in, super hot or super cold or what have you. And the OnGo play here is that a multi-tech microcell is connected into a border router that enables all of that data to come in and out of the mesh network so that all those anchors and helmets can be connected into the analytics platform. So I also wanted to touch on education. This is a segment of the market that many don't really consider because it's not so industrial, but it's very much a segment of the market that is also looking to digitally transform, with classroom modernization, enhanced security so that assets can't be hacked so easily, so that students don't have access onto the public internet and can be reached on a public IP address. Most of the schools at the moment are struggling, how they're going to plan going back in the fall. How much of the learning is going to be remote and how much is going to be physical in the schools. A lot of the school districts, they use Chromebooks, and many of them provide Chromebooks to students to be able to use. So how to connect those Chromebooks both in the school, but also perhaps at the student's house when they're doing remote learning. And then it's connecting up buses and monitoring all the transportation. So it turns out that in some school districts in the USA, 40% of students don't have an internet connection, or at least don't have a reliable one. And this is for a number of reasons, underserved communities, lack of connectivity in rural environments. And this is where with the pandemic and changes in how education is being delivered, OnGo is really delivering, phenomenal value here. Because, for example, Chromebooks can be connected, as can other types of computers, and that enables students to be able to reliably work from home and still have connectivity onto an OnGo network that has been deployed by the local school district. Wireless access points like a Ruckus R310 can be easily connected into an eCell Ethernet bridge, thereby providing CBRS best KPIs in backhaul into that school district network, and then provide Wi-Fi connectivity again to different types of notebooks, tablets, and devices. Even using an industrial router, a little bit like we saw in the oil and gas fields, that can be put into school buses, and those school buses can be driven to places where connectivity is required, where students don't have great connectivity. So, number of different use cases there. In a sense, it's classroom to the kitchen table network. Right, Safi, over to you then for an update on the CBRS Power Auction.
Okay, sure. Thank you, Dan. That was very, very good, insightful information. So for everyone's FYI, there is an auction going on by the FCC. It's been going on for a couple of weeks, and they have now completed about 34 or 35 rounds of bidding. There are 271 companies who are actively bidding. So not only the big MNO operators, but also many new incumbents, new companies are actively bidding for this PAL spectrum, Priority Access Lane spectrum. So basically 10 megahertz chunks are up for sale for every county. There are about 7 licenses per county because there's 70 megahertz of spectrum available. And so you divide it by 10 megahertz chunks, you can bid for up to 4 for any single entity. And so you can get up to 4, so you can have a 40 megahertz aggregated spectrum in 3.5 gigahertz. As shown on this chart, basically, big cities are very popular. LA is fetching about $25 million. And the total value of the auction has already crossed $3 billion. So that was very, very good for the ecosystem and for basically the backing of the industry. There's a website on the FCC that you can go to and look at the gross proceeds and then qualified bidders. And the auction will keep going until counties with demand greater than supply is not down to zero. So it is starting to wind down. And so not only the big cities are very popular, but also some of the smaller counties are popular. And what's interesting here is that even the megahertz per pop, which is basically the unit of value per size of population, is about 30 cents in some of these very sparsely populated areas. And if you look at that map and overlay on it the map of the counties being auctioned, you can infer that this is basically oil and gas enterprises who are buying spectrum in this area. And this is like West Texas and Nebraska. So these areas are rich in oil, so there is a lot of interest there. That's just one example. So really quick, just wanted you guys to know that the auction is there. And I was just checking the website live, and as of now, it has reached almost $3.2 billion, and there are two more rounds left today. So with that, I think we want to get to some questions that the audience has been asking. And so I just want to conclude and give it back to Amanda.
Thanks, Safi and Dan. Great information here. Before we get to the questions, I'm going to go ahead and drop one last poll here. If you'd like to have one of our experts contact you, please respond here on the poll and someone will reach out. All right, so we now have a few questions here, and there's still time to ask a question, so please feel free to submit using the box to the right of the presentation slides. Let's see here. We have got, what are some of the benefits of private LTE compared to Wi-Fi?
Sure, I can take that one. I think I covered a bit of it earlier, but just to recap, so there are a few benefits that come to mind. So the first one is basically security, like I mentioned. So Wi-Fi is the favorite target of hackers. It's easily, they spend a lot of their motivation and time trying to hack into Wi-Fi to sniff Wi-Fi routers or networks. LTE, on the other hand, is an enterprise cellular network, and all of those advantages of security come with LTE or private LTE. The second thing is the range. So Wi-Fi is very good for indoor or a home or a multi-dwelling unit, MDU, but it also has limited range. And on the other hand, when you look at a cellular network or a private LTE network, the range is much more extended, especially in the CBRS OnGo. I touched upon Class A and Class B devices, where a Class B device can actually transmit up to 47 dBm, which is 50 watts. And that's really a very strong and powerful outdoor unit, almost like a base station of a cellular network. So it can give you a wide range, like in a mine or a rail transport or even a city-wide deployment, for example, the school district that Dan was talking about. So CBRS private LTE has security, range, and then the cost is now equal or lower to Wi-Fi compared, because the total cost of ownership depends on how many access points you have to deploy. So for a large hospital or a warehouse or a manufacturing facility, imagine how many Wi-Fi access points you will have to deploy versus in cellular, you can have fewer of those routers that Dan was talking about, because they can transmit. Even the Class B can transmit up to 23 dBm. So those are some of the reasons why there are some advantages.
Thanks, Safi. Next question we've got here. Should an enterprise wait on 5G to deploy their OnGo networks?
Hey, Amanda, I'll take that one. No, they shouldn't. I think is the simple answer to that. It's like diving in the deep end. The big telcos who have decades of experience in deploying cellular networks are only now really just starting to dive into that, and really for them at the moment, that's just more data rate and lower latency. What enterprise is looking for is to really be able to virtualize more of that network, bring it into their facilities on-prem it, be able to capitalize more of that investment, be able to start running time series networks that have really, really low latency, to have this ultra reliable connectivity, and to jump in on all of that immediately seems a little bit like jumping in the deep end. What we're seeing from our customers is that they're jumping in today with 4G. 4G definitely is a big step up from relying on Wi-Fi and other networks that had perhaps outgrown their use. Wi-Fi 10, 20 years ago was great, right? We had a low expectation of what to expect from that. But now we've put all these business critical processes on them. So 4G LTE definitely takes the enterprise beyond that in most cases as far as they need to go. It provides them a continuity in their investment on how to get to 5G. But the real payoff with 5G is about really creating network slices, virtualizing the core network, integrating distributed control systems, and perhaps jumping in at the deep end is perhaps a bit too deep. Start off with 4G LTE and start seeing real gains out of it, and then start evolving and maturing into what 5G era technology can do for your enterprise.
Thanks, Dan. I know we're going over just a bit here. We've got tons of questions here in the inbox. I'm going to see if we can get to just a couple more of these. Next question I've got here, can private LTE networks be used for failover? How can they help enterprises in this case?
Sure, I can take that one. Yes, I think the short answer is yes. So just to explain that a little bit, traditionally, let's say you have a Wi-Fi network, then you have some security and privacy concerns. But then for enterprise, if it's a single network and it's a single technology, sometimes people are worried and they want redundancy. And because of the lack of this redundancy, a private OnGo service, private network can act as the redundant secure failover solution. So in the case of losing the primary network, the private network can act as your backup system. And because it can handle many use cases, high data rates, and the flexibility of deployment, it is a very good use case for a failover. Yes.
Great, thanks, Safi. I believe that's all the time we have got for today. I know that there were many questions that we did not have time to get to, so we will follow up with you after the event. Please be sure to check your inboxes in the coming days for the slides and the replay link. Thank you, Safi, Dan, and thank you so much for everyone that joined us today.